All right. Congratulations, you have made it this far. So, we have arrived at a very pivotal moment in this course because up till now, everything has been kind of theoretical. This is a master's course after all, um, and we have to do a little bit of theory. But now this is going to change. And so far in this course, if we do a little recap, you have learned quite a lot of concepts and things that are very, very useful, but we haven't really put them into proper use. You've done some kind of toy exercises and sort of tried things out, but things that you probably can see can be useful, but it hasn't been really proper software development. And this is what we're going to start changing now for the remainder of this course. But quick recap. You have learned, in the beginning we started looking at functions and lambda calculus, and we have looked at type theory and how types can help us both in guide us in design and in abstraction and in patterns, but also keep us safe from doing stupid things. Then we went into sort of this slightly category theory corner and looked at functors or these mappables, types that could be mapped over. We looked at applicative functors, monads, which is sort of in the sort of F# incarnation, the computation expressions. You had an exercise where you, using just functions and also some of the object-oriented properties of F#, you created a embedded domain-specific language for generating HTML or XML or JSON from sort of a specification purely using functions in F#. And all of these things are very, very useful and fundamental. Then we looked at continuations and continuation passing style and saw how we could use continuations to define the slightly simpler version of it for doing asynchronous computations, which are immensely important in real life and occur ubiquitously everywhere. From there we moved on to looking at a way of expression or a slightly different way of designing program systems, which is the actor model, which is particularly useful for doing things asynchronously, in parallel, concurrently. And then finally we sort of came up to this system which we call the model view update model or pattern, which uses this actor system or the mailbox processor to set up this system which receives either external events or interacts with the user and automatically will respond to those events. And now we are going to take this to the to its conclusion, to the next step. So now it's really time to get practical. Now it's time to sort of put on our not our theoreticians hats but our practical developer hats and see how we can become full-fledged F# developers. This is a rather large topic, of course, and I'm just going to be able to skim the surface of this. So the whole remainder of this course will be a very sort of breakneck speed exposition of some of the important things where I will try to explain and guide you in the right direction. We will look at client-side development, which back in the days used some Qt or GTK or Windows Foundation classes or whatever to do graphical user interfaces for your user, and which would run locally. But most of this stuff has today been superseded by HTML and web technology in various forms, single-page applications and so on. So we're not going to be bothering with sort of the old school stuff. We're going to be focusing purely on putting stuff in the web browser in some form or another when it comes to user interfaces. In the next lecture, we're going to be looking at how to implement the server. So today we're going to look at the client. And the next lecture is going to be the server. And I'm going to see how we can make a server backend for our client. There's going to be a little session on testing later. I mentioned mobile here. I will mention mobile today. We won't go into any details, but I will give you some pointers for that. But everything here will happen pretty quickly. This is a massive, like being a professional software developer is a lifelong learning experience, and I expect you all to be able to sort of, you will get these references, you can start digging into things and go deeper and deeper and deeper, and it never ends. And there's always new technologies, new techniques, everything cropping up. So it's very interesting, but it also is quite demanding because you all the time have to learn something new. So I expect you all to be able to read the fine manuals and use Google effectively, and Stack Overflow, of course. Right. So Fable is a very, very important technology for us. Fable is a F# to JavaScript transpiler. It will take essentially any normal standard F# and compile it or transpile it into JavaScript. It has a web page, fable.io. You can go have a look. There's documentation, all kinds of useful things that you can read about. I will demo it for you towards the end of this session. So, what can we use it for? Well, typically single-page applications. This is sort of the modern HTML5 web application. All of you have used Gmail and probably Word, even Word and Excel and so on in the web browser. That's pretty much single-page applications in JavaScript. Now we can start using F# instead and compile F# to JavaScript. We can target Node. So if you have any if you are working on any system where Node is sort of the heart of the system, now you can start writing modules for your Node systems in F# instead of JavaScript. You have heard me say many times that JavaScript is not really it has improved a lot, but it's not really a very safe language to write in, and it's very easy to create unmaintainable spaghetti with it. So Electron Apps, things like you probably have used the Slack client or Visual Studio Code, for that matter, is an Electron app. You can start doing Electron apps right away in F#. If you want to do mobile, React Native, again, JavaScript is a key element of React Native. So you can just write F#, emit JavaScript, and with a little bit of trickery, you can inject it into the old React Native machinery, and suddenly you have almost native-like mobile applications. Visual Studio Code, of course, our favorite code editor for writing F#, is largely developed in JavaScript, and now you can start doing your own custom Visual Studio Code plugins in F# instead, with all the benefits of type safety and no mutable state, and so on. All the benefits we get from functional programming, and so on and so on and so on. Like pretty much we can say that any place where you would normally put in JavaScript, and you would write JavaScript by hand or TypeScript and then interact with the system, you can now replace that process with F# using Fable. So this is an extremely powerful tool. Extremely powerful. So some of the practical stuff with Fable, because first time you hit this thing, it can be a little bit overwhelming in a way. So Fable itself is written in F# and compiled with itself to JavaScript. So it's a JavaScript component, so that you download the whole Fable compiler, everything, using your normal your normal JavaScript development tools like NPM or Yarn. We usually prefer to use Yarn. Why, I don't really know. Somebody told me that Yarn was kind of somehow better at resolving versions and stuff with, I don't know, I don't care. So I'll be using Yarn. If you like NPM, go ahead, use NPM. The whole driving thing behind behind Fable is Webpack. So Webpack is sort of the thing that will start the compiler, run through all the things that it needs to do, all kinds of background stuff, and compile your code and pack it up and minimize it and make it a nifty little package that you can include in a web page or in your Node program or in your Electron app or wherever. So this is sort of the thing. So what the complications here are is that, one, you have to deal with Webpack, and Webpack is kind of, it's not too bad, but it's sort of it's a pretty large and JavaScripty thing. And then you have to deal with all your JavaScript dependencies, because of course you want to have all kinds of things that you pull in from JavaScript that are already there. You don't want to rewrite everything from scratch in F#. So you probably want to have loads of NPM dependencies that you need to manage. And then this whole thing is of course based on .NET, so you're going to need .NET packages for F# to function, so which means that you're going to need to have the whole .NET machinery set up, and you're going to have to deal with packages there. And then we're going to be using Packet, which is a nice front end and front end to the NuGet packaging system. So this is sort of adds an extra layer of complexity. So so far we have been looking at just having .NET and NuGet packages and managing those with Packet. Now we have to add this JavaScript layer and have JavaScript dependencies to be managed by Yarn, and then run half the compilation typically for the server is run with the .NET command, and the other half for the client is run using Webpack. So this is a little bit of a extra complication, but once you get used to it, you don't really have to even think about it. So then when we finally have our Fable compiler in place, the first thing we want to have is Elmish. And this is a ready, batteries included model view update implementation that we can just pull in and use. And you have already seen the model view update. This is exactly the same. So simple little thing. We pull it in and then we design our reactive web applications on top of Elmish. You already had in an exercise, I think there was exercise 1, where you wrote your little HTML combinator library for generating XML or HTML using functions. Now, we don't have to do that ourselves, of course, and there are a number of packages that we can use and pull in. The latest incarnation of such a library is Feliz from Zaid Ajar. And it's pretty new, and I hadn't actually looked at it in any detail or used it before I did this demo, but it really is quite nice. It's slightly different from the one that you did in your exercise, but you'll quickly get the hang of it. It's in a way a little bit simpler to use. It has better type safety, and yeah, and the code just gets less messy and easier to structure and read and indent and everything with Feliz. So I highly recommend going for Feliz. The other alternative you have is Fable React, which is the traditional one, which is pretty much what you implemented already yourselves. I'll show you the differences when we get to the demos. Both these have in common that they are generating not directly HTML like your library did. They are interfacing to React.js, which is again pretty much a sort of become an industry standard for efficiently dealing with creating and updating and changing the document object model in the browser so that you can do interactive changing web interfaces. And it uses a technique called VDOM, which is the virtual DOM. So basically, whenever you change a little bit, it doesn't redraw the whole thing. It just has to redraw the thing that has changed. And it has been super optimized. So that's why everybody is just targeting React. We don't see React. We don't smell it. We don't know about it. But it's there in the background. It's running just everything gets compiled down to something which is essentially React.js. If any of you have used it by hand, which I haven't. So if you want to make a web app, you can just do HTML or whatever React components, and you can get the structure of things, but it will look like something the cat dragged in. It's not going to look nice. So of course we're going to have to do some CSS stuff. And many of you are probably familiar with things like Bootstrap, or maybe you have even done some CSS stuff yourself. It's a lot of work. Bootstrap is great, but it's kind of hard to change and extend and modify, and there's all kinds of it was the first, and a little bit like C++, a lot of mistakes were made. So Bulma is a modern new CSS component based styling system, and luckily for us, Feliz comes already with a Bulma component interface, which I will demo for you a bit later, so that we can take things that just look like plain HTML and turn them into nicely formatted components. So there are the links to both Bulma and the Feliz Bulma libraries. Typically, when we are writing client applications, they are not just living in the browser. They need to communicate somehow with the outside world. And even though this communication is going to be the topic for the next lecture, I'm just going to mention these libraries, and I'm going to show them to you, at least the JSON one today, so that you have seen it. And there are a number of these JSON parsing libraries and other libraries that you can use, but there are two particularly nice ones to use because they are really convenient. They are just I think this is one of the poorest named library or system ever. I don't even know how to pronounce it. And it's hard to type. But apart from the name, these are both great things. So this JSON thing is a JSON serializer deserializer library. So it allows you to take pretty much any F# type and convert it directly without having to do more than just a single one-liner thing. It will figure everything out for you, and it will turn it into JSON, and you can send it over the wire, which you can do with fetch, which is sort of built on the top of the standard JavaScript fetch system, but also again makes life considerably easier for us. And the same thing is that if we go to some using fetch to do a get from some endpoint, and we get JSON back, we can just feed it into thoth JSON decoder and have it decoded for us into standard F# types directly. So we never have to muck around with any of the JSON directly. Very briefly, if you get slightly deeper into things, you're probably going to find some JavaScript libraries, probably maybe something that you wrote earlier or that somebody wrote that you can't find a ready-made interface for. And so I'm gonna show you just one of the simplest ways of getting external JavaScript stuff into Fable. Just scratch the surface. This is sort of a little bit of a technical. It can, if you really want to get deep into that stuff, it can get a little bit hairy. But the simple stuff is super simple, and then yeah, you can read the fine manual for the rest. When it comes to mobile applications, there are a number of ways you can do mobile application development with F#, and they're all pretty good. The one that we prefer in my group currently is using React Native. And Martin from my group has put together a super nice Fable React Native how-to on GitHub. So if you're interested in doing mobile applications, go in and have a look at it. The really nice thing about this React Native stuff is that it uses exactly the same machinery as the model view update. So you can take your standard web application, and all you have to do is just change the HTML tags to some React Native tags instead, and then do a little bit of micmac here, and boom, you have a mobile application. So you can. It's quite nice actually. There's also a Xamarin project called Fabulous, which is coming along quite nicely. We were toying with it a year ago, and then it wasn't so nice, but it's improving all the time. Don Syme, who is the head of the whole F# compiler development, in Microsoft they have a system where if you have been sitting in the same chair for too long, they're going to send you off to somewhere to learn something new. So he has been part of the Fabulous team now for a year and a half, I think, and they have really improved that a lot. And the third possibility you have if you want to do really simple stuff is that you can use Cordova or PhoneGap, which is essentially just a wrapper around the web view in your phone, and you can take your web application and just squeeze it into a mobile app, and then some special libraries to get access to location and cameras and contacts and what have you. So that's the sort of, all of these work nicely directly with F#. Pretty straightforward, unproblematic. Finally, I think I want to mention this. JavaScript isn't everything, and an up and coming technology is WebAssembly, and that's it's really interesting, and you can do amazing stuff with this stuff. So there's actually another F# to JavaScript compiler. It's called WebSharper. It uses quite a somewhat different approach from Fable. And it's a lot older than Fable, and it also has commercial support. There's a company in Hungary who is making this system. Most of it is open source. It's all on GitHub. It's high quality, really good, and the guys are really doing some great stuff with this. So I have the hugest respect for WebSharper. Adam Granitz, who is the head of and owner of WebSharper, he did his PhD together with Don Syme, so he knows what he's doing. But they have created a thing on top of Blazor, which is Microsoft's WebAssembly technology, and they have called it Bolero. And if you're interested in those things, go and have a look what you can do with Bolero. It's quite amazing. Very nice. That's just a little advertisement for the WebSharper guys and for WebAssembly. So now it's time for demo, but I need to take a quick break and have some tea. All right. So it started to get a little bit chilly outdoors, so I decided to get into the International Space Station instead. Right. So let's have a quick little demo here and see how these things work. So what I will do now is I will demo Feliz and Fable, and I will use the Feliz .NET template directly. Now, be warned, the Feliz template isn't the greatest, and there's a lot of stuff with it I don't really like. It doesn't use Packet, and it's not and it doesn't by default even use Yarn. So, but I'll show it, and then I have done like Ingrid Espelid. I have cheated a little and set up a project where I have some stuff, which is basically the Feliz template, but I've converted it with the packet and added some dependencies and a little bit of stuff there. Tiny things. I'll put everything on the web so you can have a look at it. But just let's look at what the project looks like and compile it and see what happens. So let's see. Right. So here is I'm in my demo folder, and I will do a .NET new Feliz, and I can call it foobar. I will just run this. I've installed the Feliz template using .NET new -i feliz.template. So if you want to try it out. Right, so now I have should have a new folder called foobar. Let's look how it looks like. So here we have created a solution file. There's a NuGet config. When using packet, we don't need that. There's a README. There's a package log file. That's for npm. Using yarn, you don't need that. There's a package.json file which contains, we can have a look at it, package.json. It contains all the JavaScript dependencies for this project. So you can see there's React, React DOM, Remote Dev, Fable. Fable is a JavaScript transpiler or something. There's Fable Loader, Core.js, blah blah blah, Fable Loader, Fable Compiler, CSS compilers, and so on, and Webpack, and a little bit of stuff. Right. So that's what's inside that. So that keeps track of the JavaScript parts. In this case, when we're using NuGet directly, all the .NET dependencies are inside the project file under source. So I can show you that source app fs project. You can see this is targets netcore 3.0, 2 files, app and main, and then there are direct package references here. The problem with using NuGet directly is that you have to manage all these versions yourself and make sure that they fit together. Whereas packet, you just say that I want the latest compatible of ever, and it will just try to make everything fit together for you. So that's a good reason why to use packet. There's a public folder with some artifacts like fav icons and what have you. Yeah, the source directory, styles where you have some CSS stuff, tests we're not going to care about, and then there's webpack config.js, and this is this is what drives the whole thing. It drives the Fable compiler really, and this is something you don't really have to touch. It usually comes up set up in a nice default way. But it's just a whole bunch of JavaScript for that Webpack will read and execute and configure itself with. Right. So let's try to build this thing. So first we have to do a yarn install, and that will run and fetch all the JavaScript stuff that we need. Puts everything under node modules in the source directory. There we go. We're almost done. There you can see node modules, and yeah, then that's it. Then we can run yarn webpack. That's all we have to do, and now we just have to wait. So it says bundling for production. It kicks starts the Fable compiler, and now it's compiling our project and some dependencies for that project, and it's done. And we can go up and say, okay, it created a deploy directory. We can go into deploy, and here's an index HTML file, and it's really short, contains the fav icon stuff and style sheet, body, div, id, Feliz app, and then there's a JavaScript reference. Note that the JavaScript has these vendors something. So these are sort of hashed files, which will make sure that the cache in the browser cache is invalidated, that it always loads your stuff. If you're just calling it vendors.js and app.js, your browser will think that it already has the file and it won't get your latest updates, and you'll be in tears sooner or later. The interesting here is that the whole body part of this HTML file just has this one div, and when this JavaScript starts up, it will find this Feliz app tag or this ID, and then it will just replace it using React and start building a whole new DOM with all the elements and changing it back and forth and the whole thing. So that's essentially how these apps work. Now I've cheated a little bit, so I've already fired up this page, so we can go and have a look at it. Oops. So here it is. And you can see it's not exactly pretty. 2 buttons, increment, decrement. You can increment, it will go up. If you press decrement, it goes down. And we can press Ctrl U, and we can look at here's the HTML that we looked at. And yeah, you can see that it's the same. So there's not really much there. But if we press F12 and open the developer things and go and look at elements, you will see that it has actually created, there's the scripts, and there's a head. Oops. The head has the same stuff, but then body, there's the div with the Feliz app, and then it has added underneath there a button and a H1 tag, and then as we press these, it will change. So this is sort of the app. We'll look at the code in just a second. So you can see this is pretty, well, but ugly, because it doesn't have any styling. So we're gonna then take this as a starting point and start improving on this app. Yeah, okay. So all right. So let's get to Visual Studio Code. Okay. So here's pretty much the same project that I just created, but I've modified it a little bit. I've added packet and so on. So let's have a look at the code. App FS. Here it is. It's in a module app. We open the Feliz and Elmish namespaces. It defines a model, very simple record type, contains one member count, which is an integer. There are 2 messages. Now by this time you should be very familiar with this after the MVU thing. So there's the model, there's the message, there's 2 messages, increment, decrement, the same one that we had actually in the demo, MVU demo. Our init function sets count to 0, and that's it. It doesn't return any sensible command. Our update function will check whether it's an increment, and it will increment the counter. Decrement will decrement the counter, and then we get to the heart of this thing, the render. Takes the model and the dispatch, and if you remember, the dispatch is not just the mailbox processor post function that gets fed into this thing when it's called. Now, you already looked at you have looked at the sort of Fable React style HTML combinators. Now I've used Feliz, and it's slightly different because in the way the one that you created yourself, you had like a function which is like div, and then you had the list of attributes, and then you had the list of child elements. Now Feliz does away with this, so it will actually have a list of attributes and elements in one list, and this makes things a bit easier a lot of the time. It also has this thing that things are namespaced in a slightly different way. In Fable React, you can just open the HTML namespace, and you will have functions like div and button directly. But these are in Feliz, these are static methods of the HTML class. which means that you have to call them with the HTML prefix, which is kind of useful. You will see when we get to Bulma. But this is it. So this is the whole thing that I just showed you, and here it's been compiled in the background. One thing I wanted to show you though is that here I'm running Yarn, not Webpack, but Webpack dev server, which is very nice because it will compile the whole thing. It will watch for any file changing, and if it changes, it will recompile whatever dependencies it needs, and serve it directly to the browser. And one thing that it does nicely is that it uses hot module reloading. So I don't have to reload my browser all the time. It will do it for me. It will just update the parts of the state and the DOM that have changed. So it's very convenient, and it makes a very nice development cycle. So for development, Yarn Webpack dev server, and for distribution, Yarn Webpack, and then you can put it wherever you want on GitHub pages or wherever. So this starts a web host, a server on listening on port 8080 by default. Okay. So I thought we could improve on this example a little bit. So one of the things that I want to add here is that I want to open Feliz.Bulma, so we can pull in the Bulma things and make it look nicer. Let's see. I had a yes. All right. So we can go in here and we can say, instead of having HTML div, we can say change this into Bulma container. That's pretty much all I have to do. And then we can go to the web browser and see what happened. And you can see that the only thing that really happened here so far is that instead of being squished up in the corner, it has now been sort of moved more towards the center of the screen. Well, that's already a start. So now we can change this HTML button to a Bulma button. And we can have a look. And now you see that the buttons that were really super ugly are already starting to look kinda little bit nicer. Okay. So what else can we do? Well, we can say fine. Yeah, we can just change the styling on them. So we can say, okay, prop. Oh, sorry. This button thing, and I can say the first one could be, for example, is, what should we say? We could say is success. And I can take this one and I can put them here, and I can say it is primary, right? And we can go and look, and now you see we have gotten colors on these things. So that's pretty good. But they're sort of squished up together. So let's see if we can fix that little thing. So I can go in and say, oops, prop dot right. Oops, prop. What's this? Sorry. Oh, sorry. Style. Oh. Right. Is it margin right? Yes, margin right. And let's give it 10. Oh. I'll have to do. Sorry. Prop Yes, style. There we go. Okay. Right, so now we can go and have a look at the web page, and we see that now these two things have become nicely separated there. So we've seen a little bit of how we can style things. Let's move this header up here, and it's not really looking very good. So instead we can do something like this. We can say title. Sorry, not HTML title, but we can do Bulma title. Let's do a title 3. It doesn't have to be so huge. Count is plus string, and then of course we have to add some parentheses around the whole thing. All right, now we can go back, and you can see now we have a. It's starting to look pretty good. Now we can. So this is sort of shows a little bit about the styling that you can do with Bulma. So this wasn't super impressive yet, but let's build a little bit on this thing. So for one of the first things we're going to do is I'm going to remove these, and we're going to change the model and see. Oh, I took too much the model, and add a new one. So I'm going to add a new type here, which is the person, which is a first name, last name, and a optional alias name on somebody. And then I'm going to add to the model. We're going to keep the count, but I'm going to add a list of people. And then for the future, I've already added a Boolean option, which might seem silly, but I'll show you why this is useful, so that we're going to be able to sort things. All right. So now you see that I got red wiggles on my init. So let's fix that. Let model equals. Sorry, do it nicely. Count is 0. So the reason it's complaining is just that I'm missing some of the entries here. So I need to have a default people list. People equals empty list, and sort. We just put it to none. All right. And our app is still working. I haven't really changed anything. We just changed the model. So let's add a way of loading some people into this system. So for this, I'm gonna do it like properly now. Like this would have a server. So I could have set up a server and tried to do things. The problem is that trying to contact servers from JavaScript is a pain because of all the insecurities in the world. So there are all these things called cores, cross-origin, resource sharing, blah blah blah, and the browsers will refuse to load things. And now I have to take a break. Yeah. So instead of using an actual server, I'm gonna simulate. In this example, I'm just gonna simulate the server. I'm gonna do exactly all the stuff that I would do, like when using or contacting a API server, except making the actual call. So the first thing I'm gonna need here is this thoth.json thing. And I have prepared a little JSON snippet that I'm going to use. I can show you. It's in data.fs. It's just something, just a constant called data containing, well, JSON that we're going to be using instead of actually contacting a server. So what we want to do in this example is we want to populate this list of persons and show them. So I'm just gonna add some elements to my interface. The first thing I want to do is I want to put in a horizontal rule. Oh, missing the HTML. I'm still not quite used to Feliz. I tend to do things the Fable React way. So now we can go back and we can see that we have gotten a nice line there, and we can go back. And now I want to create a table. So we're going to do HTML table, and we're going to populate that. And here's a little quirky thing. This table here, if we go and hover over it, so this is a little quirky thing that we find in Feliz, is that this takes a list of not iReact elements, but iReact properties, which means that we're going to have to put all the child elements in a prop children list. Why this is like this, I haven't checked, but I'm sure there's a good reason. So here we can now put in an HTML head, table header, and in there we can put in, instead of using table data, we will do HTML TD. We're just gonna do, so here we're gonna do a string. So this is one of the nice things with Feliz, that you don't have to put everything in lists, because if you're just gonna do a simple thing that just contains a string, I can just type it in directly. So it sort of gives me gives me the that convenience. So this is going to be first, and then let's do last and alias, and that was the head. You can copy this and put it in here and make a table body. Ow, the cat is sharpening its claws on my leg. Ow, ow, ow. And then we'll create a table body. Now, this we're going to generate nicely. So this is one of the super nice things of not using some kind of weird, crappy templating language. We have the full F# language at our disposal. So I'm going to do a for loop, for I in, and then we're going to do model, people, and oh, there's the cat. For I, oh, sorry. Yep. Right. Do, and then we're gonna do a HTML HTML table row, and then we're gonna populate that table row with HTML table data, and that's going to be I first. Copy this and then go down to, oops, get rid of that thing, last, and then, well, now the alias is an option, so here we're going to have to do a little bit extra. So we're going to say if I is I.alias is sum, then I alias dot value, else nothing. This is one way of doing it, but that's of course not the super functional way of doing it. So a much more functional way of doing this is that we're going to realize that option is a functor. So we're going to do option. Actually, we're going to just use default value, empty string I.alias. I'll not use the functor at all. Sorry. Right. So this is sort of a much nicer way of doing it. Now we can go and look at our what we have produced. First, last, alias, and well, there's nothing in our table. yet, since we haven't populated it. So the table is empty, so it's not showing anything really. So now we need to do some stuff to actually load this table. So let's go back and let's create a button here, and we're going to use a Bulma button as up there, button, and let's say that this is button is info. I will make it blue, I think, and do a prop on click. And when you give it a function, we don't care about the click event at all. It doesn't contain any useful information, so we just make it ignore that, and we say dispatch load. So this is a message that we don't have yet, but I'm just creating it. And I'm gonna do a irritating pop-ups. Prop text load, and now the thing is, I can only load this once, so I'm going to do a little trick here, so that I can say, okay, if thing have been loaded, don't reload anything. So now I can do say here button is active, which is a, I think, oh no, is okay, sorry. So then we can do it like this. If model people length is greater than 0, which means that then I have loaded something, then button is this, oh, what was it called? Button in is in, I had it. Oh crap. Is this, no. Sorry, 2 seconds. Yeah, sorry. Not used to this Feliz yet. Prop disabled, else button is active. So why is it complaining about this? Prop disabled, okay. Maybe I need a parenthesis around the whole thing. I didn't like this. Oh, disabled. True. Yes, I don't actually think I need the parentheses. I think I can get rid of those. Yes. Right. So now if it's loaded, if it has been loaded, then the button shouldn't be active anymore, and otherwise it should be. And now only the thing that remains is implementing this load functionality. So let's go up here and add a load. Add a load message, and then we can see that we get a yellow wiggle, again a warning under this, which states that it's missing the load case. So let's check load, and then now we need to have some way of fetching this data. So now I've cheated a little bit, so I'm just going to go up here and click on this, and I have implemented this fetch function. And now we get to a little sort of working with the MVU, a very common pattern. So just wait, I'm just going to fix this load and say that, okay, load should call fetch people with the model, and that's it. Now, fetch people, what it will do. So here I'm using this thoth JSON thing, and I just ask it to automatically generate a decoder for a person list, where the person is the type I defined up here, and I want the list of persons. So this will make a JSON decoder for a JSON list corresponding to that type. You can create these. Sometimes you also need to create your decoders by hand, but often it's good enough to just use the auto decoder. They are not maybe the fastest and most optimal ones, but very convenient. So I usually start there, and if it doesn't do the trick, then I do them by hand. It's quite easy to do them by hand as well, and it gives you loads of control. Now this is a little bit overkill, not having an actual server available, but this is to demonstrate how one would call a server thing. So I create a function which takes a unit argument and returns a promise. Now, a promise is the JavaScript native thing of an async. In principle, we can use async. These are sort of equivalent, and you can use async with Fable, no problem. But the reason why we are using promise here is that if we would use async, then it would have to be translated by using a little shim from the F# async to the JavaScript promise implementation, and that costs some extra cycles. So this is a sort of a little optimization for things to go faster. From our perspective, the only really difference here is that the promise is just the string promise instead of async. Otherwise, it's all the same to us. So we just create this function, which I just call p because I'm lazy, and you see that it's a function from which takes unit and returns a promise with a result of a list of a person or an error, which is a string. So this is what is produced by the decoder. So decode from string, if we look at that, it will produce a result with the JSON or not the JSON but the F# type, and if it can't parse the thing, it will generate a string. And then fetch people here will return the model. It doesn't change the model yet because it has nothing to change it with. And then instead of having command none, it calls command of promise either, which gives us the possibility of saying, okay, either thing went okay, then do this. If there's an exception, do this. So I say, okay, here's the promise. Here's the argument to the promise. This is the message that you need to wrap the result in if everything went well, and this is the message that you need to wrap the result in if it failed. Now you can see those are red, so I haven't created those. And this is a very typical pattern when calling APIs. You have something that triggers the API call, which in this case is fetch people, and load, and then you need to have a new message to handle the response. So I'm going to create that up here. I'm going to call it load handler of, and then I know that this thing, I could look at this thing here and say, okay, fine, this returns a result of something. So I know that this is going to be a result of person list string, and you see that now the red wiggle has disappeared. And then I need something to deal with the exception, a message for those. I'm just call it exn of x of x. Why did that happen? Oh, I need to, of course, open system, I think. Yes. Missing a system. So now I have my messages. So that's all fine. So now this thing will, if I get the load command, it will call this thing, it will send it off to the load handler, but we haven't implemented that. And we can see that now again message is saying, oh, yellow wiggle. So I'm gonna add here a load handler X, and then I'm gonna say handle load model X. Actually, I think I have cheated again, so I have it pre-implemented here. So I have load handler here. Oh, I see. I've done it in line directly, so I could just put it here. Right. So load handler will receive this result with a list of persons or an error if it couldn't parse. I match it with X, and if it's okay, people, I will return model with people updated with P, and I'm done. If it's an error, I print it. And I also need to have an exception handler, exn of, exn, and that's going to be a very simple exception handler, printfn error or exn %a exn and model comma cmd none. So here we have, that's it. Now we have the handler and we have the exception handler, and everything is green and peachy, and we can go and look at how it looks. Now there's a load. Let's click it, and lo and behold. And now you can see the button is disabled after I loaded it. But the table is, not nice. So let's see if we can style the table a little bit so we can get the slightly nicer view here. So let's see. Let's go down to the table, and of course the first thing we're going to do is change it from an HTML table to a Bulma table. And then we can go back and see how it looks. Well, that was an improvement. Just one little change from HTML to Bulma, and now we get this table that actually looks already quite a bit nicer. So let's see if we can do something else. We can add some more props to it. Prop. No, we should have table is full width. Table is hoverable. And now we have this nice hover effect, and you see how the table suddenly became full width. We can look at some other options here. Is striped, and now we have a striped table. So you see how Bulma makes it reasonably easy for us to make things look kind of nice. Instead of striped, we could have tried something like is bordered, and we get this look on it, and so on. And the other nice thing with Bulma is that it's actually reasonably simple to go in and hack the styles. In most of these templates you have a style CSS file where you can just put in whatever customizations you want, and it will be automatically included in your code. So, but let's use is striped instead. So there we go. Oh, I used the wrong. I should use th. Oops. Th table head. So now it's gonna be even better. Yes, now we got boldface up here. Right. So now we have this table. So this one thing that I just tiny little improvement that I think we could do. We could of course improve the formatting of this so that it doesn't look like. So it's easier to read. A very common thing that one wants with tables like this is being able to click on things and sort them. And I'm just going to do a very quick and dirty sorting thing here. So I already added to the model this sort bool option. And the idea of having a bool and option is that if it's none, then it's unsorted. If it's sum true, then it's ascending, and if it's sum false, it's descending. So let's add some sort handlers to the code. I have already added a handle sort function here for the thing, and then I have a helper function which is called sort order, which implements the logic that I just said. You can look at it. All right, so toggle sort order. It takes a bool option, which is the sort up here. If it's none, then it will just set return sum true. If it's sum and contains a value which is true, if this value is true, then it will set it to false, and otherwise it will just set it to none again. And here's the handle sort. We'll look at that in a moment. So let's go back to the table and say, if I click, and I'll just do this on the first on first name, so we can only sort on first name. You can do that, the rest by yourselves later. All right. So table head. So now I'm going to need to add some properties to this table head thing. So I'm going to put it in a list, and then everything's going to get red. So this here will now change from just being text to a prop text first. And then I'm going to add a prop on click, and we'll give it a function. Ignore the argument, dispatch, and I'm going to say sort, and I'm going to have to add to this, I'm going to have to add the current state of it, which is model sort. So now when I click on it, it will send off this new message sort, which contains the sort. So let's go up. We are missing in our model, we are missing this sorting message. So now I can say sort of bool option. All right, so that's fixed. And then I had this handle sort method, so I'm just going to add it to my update loop. Sort x handle sort, and it needs the model because it will return a new model for me, and x. And now we can look at the handle sort. So it will take the current state that I dispatched via the message, check if it's sum. Well, then it should sort up, and then it creates a new list of people, which is if up, then list sort model people, else sort descending model people. And then I just update the model and say replace with the sorted list of people, and I call this toggle sort order to set the new sort state. And if it's none, set sort to none and don't do anything. So it's fairly straightforward. So now we can go back and have a look at the user interface. So now let's see what happens when I click on first. Oh, maybe I have to try to reload. Something went wrong. Let's see what that could be. I call it sort there. Hold on. All right, so I actually figured out what it was. I was missing, of course, an HTML.tr. element, which I'm just going to add here, and then we're just going to indent this stuff properly, and now hopefully everything is okay. And nope, let's see what happens here. Load. Strange. Okay, it's getting late. Yeah, so I'm sending, of course, the same model back all the time, so nothing is changing, and of course nothing is going to happen if I do that. So what I have to do is, of course, send sort and toggle sort order of model sort. So now I'm gonna just break the line here so that it will get nicer. So and I'm missing a parenthesis, and now I really hope this is yes. And now you can see how we can go. This is unsorted, sorted, reverse, and unsorted. So now that works. So that was just a little messaging problem we had there. Right, so there's one little tiny thing that I want to mention and scratch the surface of before we conclude this session, and that's JavaScript interrupt. This is not something that you're gonna hit very quickly, but it's nice to know, at least have seen it once, how it works. So there's a lot of really nice JavaScript libraries out there for graphics and for whatever, all kinds of things that you want to be able to interface to, so that you don't have to rewrite them, write them in F# from scratch. And of course Fable is already leveraging being able to interface these things a lot, like using React.js and so on. So it will happen that at times that you have JavaScript code. Maybe it's something you have written yourself, maybe your colleague wrote it, maybe it's some library that you found that you want to be able to use and use it as if it was a F# library, but in the background, when it gets compiled to JavaScript, it just calls the JavaScript library. So I'm going to show you one of the simplest ways of doing this interop between F# and JavaScript. Just a quick little example of how it works, and you can look in the Fable documentation for all the details on how to do it. It's most of the time pretty easy, but it can get kind of nasty. So my usually our strategy at work is just to do as little as possible. So if you have a huge library and you just need a little piece of it, well, just interface the little piece you need. And if you read more in the future, we'll do it in the future. All right, so let's have a quick look at how this works. So I have created here a JavaScript file, and it's written in modern JS6. I don't know if that JS6 is modern. What is J6, 7, 8, 9? I have no idea. But this is, at least according to expertise, this is at least modern enough for our purposes. So it says this should export a module with a function in it that has which is called hello, which takes a argument what, and it returns a string hello what. And actually, since this is JavaScript, I think we should say what. So this is a trivial little example. So the way to make a F# interface for this advanced function here, I have created an interop fs file. You can do it wherever you want, but I just put it in a separate module. You need to open up Fable core. There's also one called Fable core JS interop with more advanced stuff in it. And the first step is that you need to create a interface for your module. and I've called it I-hello, and you define the signatures of all these functions that you have. So I have added this, and the function that you have has to have the exact same name as the one in the JavaScript. So if we go back to the JavaScript, I have a function which is called hello with small letters, and it takes a string and it returns a string, and we go back to interrupt and see that, okay, abstract hello takes a string, returns a string. And then there's this magical annotation here, import all, and I give it the JavaScript file. You can also do import selectively and things from JavaScript files. But now, since I only have this one thing in it, I just say import all ./hello.js. And then I say let hello, and this will be the name of my module. In principle, JavaScript module, it will be a like a class, which is of type I-hello, and I just say that this is JS native. And that's it. That's all I have to do. And now I can go back to my app here, and we can say, well, and we can go up here, and let's see, where are we here? And add a title. So I'm gonna do a Bulma title 4, and now I can say interrupt. There's the hello module. I can look into that, and it contains this hello, and I can say right, and we can go back here and say, oh, it says hello people. So that sort of shows how to do the simplest form of JavaScript interrupt in Fable. And this is pretty much all I had. I see that this became a mammoth episode, but so be it. The next lecture will be on ASP.NET Core and Giraffe, which would be our default go-to for creating web servers with F#. But more about that in the next lecture. Until then, bye.